Hi students, in today's class we are going to discuss about the mechanism of addition polymerization. See, the mechanism of addition polymerization can be explained by these two types. One is free radical mechanism and the other one is ionic mechanism. See, all the above mechanisms occur in three major steps: initiation, propagation and termination. See, first we will discuss about the free radical mechanism. See, here in the initiation, it is considered to involve two reactions. The first reaction, it involves the production of free radicals by homolytic dissociation of an initiator or a catalyst to yield a pair of free radicals. See, here I is an initiator and it dissociates into two or free radicals. Examples of commonly used thermal initiators. The thermal initiator is a substances used to produce free radicals by homolytic dissociation at a very high temperature. See, these are some of the thermal initiators. Acetyl peroxides at 70 to 90 degrees Celsius, it forms the free radicals like this 2CH3COO minus. Here this bond is broken and one electron goes to this and one electron goes here in this side. So by this way it forms two free radicals. See, here in the same way benzyl peroxide and 2,2-azobis isobutyl nitrile forms free radicals. The second reaction, it involves the addition of these two free radicals to form the first monomers to produce chain initiating species. See, here this free radical reacts with the monomer and forms the chain initiating species like this. It is formed in these two double bonds. One bond is broken and the electrons are splitted in these two carbon atoms and it combines with this R and form this chain initiating species. And the next step is chain propagation step. It involves the growth of chain initiating species by the successive addition of large number of monomers like this, and the chain initiating species reacts with n number of monomers, forms a growing chain, and it is otherwise called as living polymers. The chain is terminated by two methods. The first method is coupling. It involves the coupling of free radical of one chain N to another free radical, forming a macromolecule. See, here in this way, the two free radicals combines to form and it forms a macromolecule and it is a dead polymer. The other method is disproportionation. It involves transfer of hydrogen atom of one free radical center to another free radical, forming two macromolecules, and here one is saturated and the other one is unsaturated. Like this it is formed. The product of addition polymerization is known as dead polymers. Next is we'll discuss about the ionic polymerization. The ionic polymerization is faster than the free radical polymerization. The ionic polymerization is initiated by the positive cation or a negative anion. Depending upon the nature of the initiator, it is divided into two types. One is cationic polymerization or carbonium ion mechanism, it follows, and the other one is anionic polymerization and it forms carbanion mechanism. See, in the cationic polymerization, it takes place when the electron donating groups like CH3, C6, H5 are present in the monomer. These groups stabilize the carbonium ion formation. See, the example is the formation of styrene and isobutylene and isoprene. Here the catalyst used for the initiation reactions are Lewis acids like AlCl3, BF3. See, in the initiation step, it involves the formation of chain initiating species. For this, the catalyst acts with the co-catalyst. Here, the co-catalyst is water and it forms the H plus and AlCl3OH minus. See, here this AlCl3OH minus reacts with this monomers and form chain initiating species. In the propagation step, it involves a chain growth with the successive addition of large number of monomers. See here, this species, the chain initiating species, reacts with the monomers and form the growing chains. In the termination step, the growing chain involves a removal of the catalyst with the addition of proton and with the counter ion. So like this it forms. See, it is a chain initiating species, and here it takes one proton and it forms a catalyst, and it forms a macromolecule also. Next, in anionic polymerization, it takes place when the electron withdrawing groups like Cl- and Cl are present in the monomer. These groups stabilize the carbanion formation. See, the example is the formation of vinyl chloride, styrene, and acrylonitrile. And the catalyst used for these reactions are sodium, sodamine, potassiumine, and lithiumine. In the initiation steps, it involves the formation of chain initiating species. The presence of KNH2 forms K plus and NH2 minus, and this NH2 minus reacts with the monomer and form chain initiating species. And the propagation step, it involves the chain initiating species by the successive addition of a large number of monomers, and the negatively charged ion simultaneously shifts to form a newly added monomer. So here the growing chain is formed, and in the termination step, this chain is terminated by the addition of ammonia. At the end, we can get the NH2 minus back. So thanks.